Hello students, welcome again to the class of number theory. So as we have studied in the previous lecture, we were discussing about greatest integer function. We know greatest integer function is greatest integer of x is equal to largest integer contained in x. So therefore we can write x can be written as its integral part plus its fractional part. And the condition of the fractional part, it is greater than equal to 0 and it is strictly less than 1. So now we are going to prove the properties of greatest integer function. Our very first property is greatest integer x less than equal to x is less than greatest integer x plus 1. So we have studied x is equal to greatest integer x plus r. Now r is greater than equal to 0. It is less than 1. So we use this condition r is greater than equal to 0. So then it is greater than equal to x plus 0. So therefore x is greater than equal to greatest integer x. Again x is equal to greatest integer x plus r and we use the condition r is less than 1. So it is less than greatest integer x plus 1. So therefore x is less than greatest integer x plus 1. So combining 1 and 2 we get greatest integer x is less than equal to x is less than greatest integer x plus 1. This inequality is strict inequality. Second condition, x is a real number and m is an integer. Then greatest integer of x plus m is equal to greatest integer x plus m. Now x can be written as greatest integer x plus r. R is greater than equal to 0 and it is less than 1. Adding m both sides, x plus m is greatest integer x plus r plus m. Now taking the greatest integer function both sides, x plus m greatest integer, it is greatest integer of greatest integer x plus m plus r. Here it is an integer and it is the fractional part which is less than 1. So the greatest integer contained in this is equal to greatest integer x plus m. Our next condition is third condition, greatest integer x plus greatest integer y is less than equal to greatest integer x plus y is less than equal to greatest integer x plus greatest integer y plus 1. So we are having two real numbers x and y. We write x can be written as greatest integer x plus r1 and y can be written as greatest integer y plus r2. Condition of r1 0 less than equal to r1 is strictly less than 1. 0 less than equal to r2 is strictly less than 1. Again we are to add x and y, so we add a x plus y can be written as greatest integer x plus greatest integer y plus r1 plus r2. Now what about r1 plus r2? Both numbers are greater than equal to 0. So therefore their sum is also greater than equal to 0. Both are less than 1. So their sum is less than, it is 2. So it is less than 2. We break it in two parts. Either r1 plus r2 is less than 1 or r1 plus r2 is greater than equal to 1. Now the value of greatest integer x, value of x plus y, it is equal to, in the two conditions, when r1 plus r2 is less than 1, then it is the number greatest integer of x plus y, it is equal to greatest integer x plus greatest integer y. right? Because it is less than 1 and it is greater than equal to 0. When the fractional part lies between 0 and 1, then greatest integer value is the integral part, that is greatest integer x plus greatest integer y. Again, when it is greater than 1, then it lies between 1 to 2. Then it is less than 2. We can write it as 1 plus some fractional parts is r prime. So then the number comes out to be greatest integer x plus greatest integer y plus 1. So therefore greatest integer of x plus y, its value is less than equal to greatest integer x plus greatest integer y plus 1. It has only two possibilities. It is less than equal to greatest integer x plus greatest integer y plus 1, and it is greater than equal to greatest integer x plus greatest integer y. So we can also use this prove this condition using this we have used earlier. X plus y is equal to greatest integer x plus greatest integer y plus r1 plus r2, which is greater than equal to greatest integer x plus greatest integer y. So therefore x plus y is greater than equal to greatest integer x plus greatest integer y. Taking greatest integer both sides, we get greatest integer x plus y is greatest integer of greatest integer of greatest integer x plus greatest integer y, which is same as it is integer, it is equal to greatest integer x plus greatest integer y. The same thing can be proved in this way also. Thank you, students.